A double-ended queue, often abbreviated as Deque, is a data structure that allows insertion and deletion of elements from both front and back. It is similar to queue, but it allows insertion and deletion at both ends, making it more flexible. Operations supported by Deque are insertion at the front, insertion at the back, deletion from the front, deletion from the back, accessing the front element, accessing the back element. Deques can be implemented using various data structures such as arrays, linked lists, or dynamic arrays. Types of Deque. There are two types of Deque: input restricted queue, output restricted queue. In an input restricted queue, insertion operation can be performed at only one end, while deletion can be performed from both the ends. In output restricted queue, deletion operation can be performed at only one end, while insertion can be performed from both the ends. Applications of Deque. Deques are very versatile data structures that have numerous applications in computer science and real-world scenarios. Some of the common applications of Deques include implementing a queue or stack. Deques can be used to implement both queues and stacks efficiently. Using a Deque, you can implement a queue that supports insertion and deletion from both the ends, making it more flexible than a simple queue. The second application, sliding window problems. Deques are often used to solve sliding window problems efficiently. Sliding window problems involve finding the maximum or minimum value of all contiguous subarrays of size k in an array of size n. Undo operations in text editors. Deques can be used to implement the undo functionality in text editors efficiently. You can maintain a deque of the previous states of the text document easily, undo and redo operations. Breadth first search. Deques can be used to implement the queue data structure required for BFS traversal of graphs. Breadth first search involves visiting all nodes of the graph level by level. Task scheduling. Deques can be used in task scheduling algorithms where tasks need to be scheduled based on their priority or other criteria. Memory management. Deques are used in memory management algorithms such as buddy memory allocation technique, which divides memory into partitions to satisfy allocation requests.